Hello everybody and welcome back to this tutorial. And right now what we are going to do is we will code a function for our threaded server which will allow us to send just one line of a command which will go to every PC that is connected to us, and then they will execute that command. So let us see how we can do that. If I nano my threaded.py, we will use the function reliable send, but we will copy it, we will do just some simple modification to it, and it also needs to be outside of the actual shell function. So just paste it right here. Let's tab it properly, so let's delete all these empty spaces. Tab it once, same with this line. Tab it once, same with this line, and this line doesn't have to be tabbed at all. Now this function, since I said it has to be renamed differently, so we will name it send all, or send to all, we can do something like that. And it won't take an argument only of data, it will take two arguments. One of them will be the target, or if you want to call it the socket object for that specified target, and the other one will be the data, or if you want to specify it as a command that we're going to send to that target. Now all we want to do right now is actually go down here to our while loop, and we need to code what happens once we actually call the send to all function. So right here, else if command, and then first 7 letters equal to, for example, send all. Now make sure that this is how our function will look like, or our command. So send all, for example, send all ping 192.168.1.1, which is, for example, sending all targets on my local area network to ping my router, and then they would ping my router. This is why we're using first 7 letters to equal to send all. And then we will strip that send all, and we will use just the remaining of the actual command. So we'll set a variable x, or let's not call it x, it might be confusing, so let's call it length underscore of underscore targets equals length, and then in brackets targets. What this function right here will do is it will check how many elements are there in our targets function, or basically how many socket objects are there in that list. Basically that means that we are counting how many PCs are connected to us. Then we can print that just to check it out if it works. So print length. Okay, so let me flip these two letters. So length, or actually, you know what? We don't really need to print this. There is not really a point. What there is a point is we need to set up a counter, which we can call just I. So counter I equals 0. And then we need to try to send to our targets and accept in any other case where it might actually fail. So let's code the actual accept first. We will just print to the server exclamation mark failed to send command to all targets. So we can do something like this, but in the try we need to actually code something like this. So while our counter I is smaller than the length underscore of underscore targets, so as long as it is smaller number than the length of targets, that means we need to continue sending. So first of all, we need to get the target number. So let's call that variable target or tar number. And then that tar number will be a socket object for that specific counter number, which we can specify with equals targets and then in square brackets I. That's how we are selecting an element. For example, if I is equal to, and then tar number will be equal to the socket object of the targets list element under ID 2. And then we can actually print the tar number so we can see how to who are we sending. So print tar number, and then we call our function that we coded. So send to all, and it takes an input of tar number. Let me just go right here. And this might be confusing to you right now. We want to send the entire actual command. So I will explain why we are sending the entire command and not the stripped command from the send all word. We actually want to send the command to the targets with the send all string attached to it, and I will show you just in a second why, as soon as I actually increase my counter. So we need to increase it by 1 each time. Okay, so this is it. We save this, hopefully this is all good, and now we need to go to our actual reverse shell to finish the part of code there as well. Since, as I said, we are sending it with the send all string, so we need to see what happens in our reverse shell once it receives a command with a send all string. So in order for us to not actually confuse the shell with anything else, we need to run that command that we get with the send all as a certain sub-process, so that it doesn't actually crash our connection and that we can actually even later enter our session and start executing some normal commands that we want. Now let me show you. If I go right here, we can code it right here. So else if command equals to the send all, or not the command, we want the first 7 letters of the command equals to send all. And let's close the actual double quotes right here. We want to sub-process and open a process, we want to open a command from the 8th letter till the end, which will be just the command that we sent, such as ping 192.168.1.1, and then shell equals true, and then we close the brackets, and this is basically it. Then it will open it in a different sub-process, and then it will go back and wait for the next command, which we can execute as soon as we join that session once again, or as soon as we actually send another send all command. So let's save this, let's compile it, hopefully everything will work good enough. Not Python, okay, so PyInstaller. Okay, so we need to go to scripts first, then PyInstaller, no console, one file, and then reverse shell.py. So let's copy it right here, waiting for it to compile. Then I can go to my USB drive, plug it in for my Windows 10. Let me see if my Windows 7 is up. It is. I will go to my Apache 2 right away. So 192.168.1.9. USB drive plugged in. Now we are waiting for this to finish compiling. It should be over soon enough. So here it is. And all I want to do is just transfer my reverse shell. Or not transfer, let me copy it, since I'm copying it to two different actual folders. One of them is the USB folder, and one of them is my var www.html, or the Apache 2 folder. Then I can just simply start my threaded server, waiting for targets to connect. I can unplug this. I can refresh this page and get the reverse shell.exe, save it on my desktop. Oops. Let's first go with the Windows 7, save it on my desktop and run it. This is ran. Now right here, I need to open it as well right here. So reverse shell, open it right here and wait for these two PCs to connect back to us. Then we will test the send all command by actually running a simple command making directory. So mkdir test, we will just run that command and see if both of these machines create a test directory right here on their desktops. Then you can just perform and check also with the actual Wireshark if you ping a certain machine. If you, for example, ping 192.168.1.9, which is my Kali Linux machine, and we open up a Wireshark there, we can see whether we get pinged by both of these machines, so we can test that as well. But right now, if we just type here targets, we have session 0 and session 1. If I go send all, and then mkdir test, it says it prints out the socket objects to which it sent the actual command to, so 2 sessions, which is actually true since we have 2 sessions connected. Right now, we can see on our Windows 10 machine we have the test, and right here, for some reason, we don't really have a test on our actual Windows 7 machine. Not really sure why is that. So let's try with another command. Send all mkdir lowercase test. Nothing really happens. Now let me check something out right here. Okay, so I tested everything, and basically the problem was because I used the compilation of reverse shell before we actually coded the send all function. For some reason, I don't know why I got the older version on Windows 7. That's why it didn't want to create the actual folder on our Windows 7 machine. But right now I compiled the reverse shell once again without changing anything at all, and send both of those reverse shells to the actual Windows 10 PC and Windows 7 PC. So let me show you what I mean by that. We will just start off everything from the beginning, and by everything I mean running the server and running the reverse shell on both targets. So once again, I didn't change anything, so you can run the reverse shell if you compiled it correctly previously, or if you compile the newest version of reverse shell. And now we wait for it to connect, and then we will try to create test files on both of these targets with one command. So we can see my Windows 10 has connected. We're waiting for the Windows 7 right now, and here it is. Targets, we get the session 1 or session 0, who am I? This is Windows 10, I believe. And session 1, this is Windows 7. And right now, if we just type send all and then actually mkdir test, we send that. We go to our Windows 10 machine, or Windows 7, pardon me. You can see there is a test folder right here right now, and also on my Windows 10 machine there is a test folder. So if, for example, you had 100 PCs connected to you, with this single command you would create a folder on all of those PCs. Now if you want to actually try it with Wireshark as well, you can just open up your Wireshark in Kali Linux. Wireshark, and then we can actually try to ping our Kali Linux machine from both of these IPs and see if we will get packets from both Windows 7 and Windows 10 machine. So let's wait for this to open up. Here it is. We need to go on our interface in order to listen the packets, which is ETH0. Double click on your interface, and now basically you need to filter out, so we don't get all of these packets. We want to filter out for the ICMP packets. Now everything is a little bit slow because I'm actually running 3 machines at a time, Kali Linux, Windows 7 and my Windows 10 machine. So let's actually just wait for this to unbug so we can actually use it. Okay, so here it is. Delete one I, so ICMP, press this blue arrow right here. And now we filter only the ICMP packets. So right now, if I go once again, if I go once again to my actual terminal running the connections, and I type send all ping 192.168.1.9 and press enter right here, in a few seconds you can see that we are receiving packets from both of these IP addresses. We are getting the packets from 192.168.1.5 and also from 192.168.1.6. These are just our Windows 7 and Windows 10 machine pinging us because we send them the command to ping us. Now imagine sending this to 1000 PCs. Even this ping command could present a little bit of problem to our connection if we actually tried to ping a certain target with multiple PCs. Now what you can do with this is you can upload a DDoS tool or something like that, a synflooder, so you can compile a synflooder to exe. We called it synflooder before in this course, and then you can upload to every target the synflooder and with one command run it on every single target. So simply just with one command, with just send all start synflooder.exe on every single target, will start flooding the actual connection on the specified target. So hope you enjoyed this tutorial and this section. With this, we actually finished the actual threaded server. But before we actually close up this section, I want to show you one thing that we want to quit without saving, okay, that you might have missed, or not have missed, that I missed. So you need to add it right here. So go to your threaded, and you need to add the count variable to be equal to 0 right here. So count equals to 0. And the reason is because we only copied the shell function, and the count variable is used in our screenshot function right here in order to perform multiple screenshots. So we need to increase something right here. And in order to increase it, we need to have it specified in our code. Also, one more thing you need to add is down here in the outer while loop, if you specify command that doesn't really exist. As you can see, we only have else if statements, and in the else statement we will just print else print exclamation mark command doesn't exist. Simple as that. So our program doesn't crash when you mistype target command or session command or something like that. It just prints command doesn't exist. So if you want to, you can add multiple other functions to this server if you'd like. Basically, whatever comes to your mind, you can add to it. And that would be about it for this threaded server. Hope you enjoyed it, and I hope I see you in the next section where we will continue coding. Bye!